Okay, this is 3.5. We're going to do some mathematical modeling of some random problems, and we'll also do variation, inverse and direct variation, and a combination of the two. So the first problem says you're hiking along the California coast and you come up on a redwood tree. It says you are 5 feet tall, so I'm just going to draw some similar triangles like you did for this problem in geometry. Here's you, you're 5 feet tall, your shadow is 3 feet long on the ground. The redwood tree's shadow is 117 feet. The question is, how high is that? Well, if you just draw some similar triangles, you know, because the sunlight comes down at basically parallel, directions, making this angle the same as this angle. If you're both standing perpendicular to the ground, what you have is angle-angle similarity from geometry, if you remember. So basically, you can just make ratios of corresponding sides of triangles. So you can do call this x. You can do like x over 5 equals 117 over 3. Obviously, there's different ways to do that. You can do x over 117 equals 5 over 3. There's different ways to write this proportion, but you solve it by cross multiplying. I'm just going to multiply both sides by 5, and that gives me my answer for the height of the redwood tree, which is 195 feet. Okay, the next problem says state sales tax Y is directly proportional to retail price X. So here's the formula. Whenever you have a direct proportion, it's Y equals some constant of variation, which in this case is going to be the interest rate, times X. All right. So then they give us an item that sells for $142, so that'd be $142, and the sales tax is $14.42. We can find that rate then, sales tax rate, K right there, by just dividing both sides by 142, and that gives us K is 10.15%, or obviously it's a decimal, it's 0.1015. And that goes in for my equation. So my new equation becomes y equals 0.1015 times x. So we put that here. And then wants us to find the sales tax on a $400 purchase, so we plug in 400 for x right here. Multiply by this sales tax rate, and that gives us $40.62 about of sales tax. Okay, the next problem says the stopping distance d of an automobile is directly proportional to the square of the speed v. So directly proportional means it goes in the numerator. As this goes up, this goes up. That means, or as this goes down, this goes down. That's direct proportion. But there's also a constant of variation, k, always. A car requires 30 feet to stop when its speed is 80 miles per hour. So they just gave us an order pair, 30, 80. So we can plug in 30 here for the speed and a distance of 80. I'm sorry, all the way around. 80 was the speed, and d depends on that. So 30 was the distance in feet. So this is 30, and this is 80 right here. We can find that constant of variation, which gives us 0.00469 about. So I'm going to put that here. So my equation becomes 0.00469 v squared. If I insert that for k. And then we want to know the stopping distance if we're going 77 miles per hour. So we're plugging 77 here and solve for d, and that gives us about 27.79 feet. Next question is pretty easy for me anyway. Y equals 4 over x is inverse variation, right? It's inverse variation because as x gets bigger, y gets smaller. So they vary inversely with one another, x and y. So I would just say no here. It's inverse, not direct. Next question is pretty easy too. It's no again. Direct proportion is y equals kx. So that goes to the origin, and because it's got no y-intercept. It's like y equals mx plus b, right? Except for it's plus 0, so it's got no y-intercept. The slope is k, so the slope is the constant variation of your line here. This will have slope k. But it goes to the origin. Y equals kx is direct variation. It will always go to the origin. It could go down, but it will always go to the origin. If it doesn't, it's not direct variation. Okay, so let's try an inverse one then. It says the company found that demand for its product, so I'll say demand D, varies inversely with the price of the product. So I'll use P for that. So inversely means we put that in the denominator. Now it says when the price is $4, the demand is 450. Find a mathematical model. So we're going to solve that for K right here by multiplying both sides by 4. That gives us 1800. So 1800 goes here. And that's my relationship then. And I can write that here, 1800 divided by P. And then approximately the demand when the price is $6, we're going to plug in 6 here. And this is going to give us 300. Okay, just another one of those to practice. If F varies inversely with G, and if F is 48 when G is 6, what's the value of F when G is 12? Well, first we need to find K. So multiply both sides by 6. And that gives us 288. So my K is 288. So I'm going to put that right in here. And then find the value of F when G is 12. Now I'm going to take 288 divided by 12 to find F, which is 24. Okay, the next problem is a really tough one. So I don't know what we're going to have to do about this one, but we can do it. Maybe not put it on the test, but it's a great problem for homework and for learning, how some of these problems in the real world get a little more complicated, like this one. It says, at the surface of the ocean, the water pressure is the same as the air pressure, which is 15 pounds per square inch. Below the surface, the water pressure increases by 4.94 pounds per square inch for every 10 feet of descent. So the pressure of the water is equal to this 4.94 pounds per square inch for every, I'll use units here at first, pounds per square inch for every 10 feet of descent times the feet and descent plus 15. So basically, I know this is a linear relationship because it says that it increases by 4.9 for every 10 feet. So every time you go over 10 feet, you go up 4.94, right? Only it says you start off at 15, so they gave us a y-intercept here as well. So I'm looking at this in terms of y equals mx plus b, where you start off at 15 and then you increase by 4.94 every 10 feet of descent. So it's a linear relationship from that point. So we need a formula to represent that, which we have right here. Now, it's still a little tricky because I need to simplify this, and they said they want this formula for f of x to be in per square inch as a function of depth of inches below. So they want us to be able to stick in inches here. Well, in order for this formula to work, we need inches down here then, so that when you stick in inches here, these inches cancel, and you get a pressure in pounds per square inch as your answer, because this is in pounds per square inch too, if we look at the units. So units are important, really important. We need to make sure that when we multiply by a depth, the units have to be right so that it cancels down here. So what we need is to multiply the bottom here by 12 so we get 120 inches instead of 10 feet. That way when we multiply by inches for our depth, the inches will cancel and we'll get pounds per square inch plus pounds per square inch. That way the units work out. So units are really important. Okay, so my formula then becomes this, to simplify it, if I take away the units, which I can write as, they want us to write it as f of x equals, and I'll simplify this is really 0.04117 d plus 15, and they want us to use x. So there's our formula that goes right here then for pressure in terms of depth in inches. Okay. Now the question they ask is, what is the depth when the pressure is 110? So we got to plug in 110 right here and solve this formula right here. Now be careful with the units, it's really picky. We got to subtract 15, divide by 0.04114. I didn't round that, I kept that in my calculator. And that gave me an answer of 2307.69. I did 23, and it wanted the units on here, which in that case is inches. I used IN, that worked, because keep in mind we're finding a depth, that's in inches. Okay, the next problem is pretty tricky too. It gives us two cubes and it gives us some information. It says that these two cubes, one has a surface area of 54, one has a surface area of 216. Now if you remember from geometry, we did this length area volume relationships where if the length ratio is A to B, the area ratio is A to B squared, and the volume ratio is A to B cubed. You can use this information you learned in geometry to solve this problem. They gave us the area ratio, 54 to 216, which is really 1 to 4. If we take the square root of that, that gives us the ratio of length 1 to 2. So what that means is if this length is 1, this length is 2. So we can draw this like inside here a little bit to make this problem a little easier, where we can draw like this one of these cubes inside, and you can see that you'd be able to fit 1, 2, 3, 4, 5, 6, 7, 8 cubes inside the bigger one. And if you're not sure, that's what they're asking for is volume then. It's a question really about volume. They're asking the volume ratio, which you would take this A to B, 1 to 2, and cube it to get 1 to 8. So if you remember this from geometry, you can use that. Otherwise, you have to kind of work backwards and say, what's the ratio of length then? Given the ratio of area is 1 to 4, ratio of length must be 1 to 2, which means that this cube's twice as long, which means you could actually fit 8 of these inside the bigger one. Okay, let's do a couple problems of joint variation then. It says P varies jointly as T and R, and inversely as Q. Now there's still going to be some constant of variation K there. Let's find an equation for P if P equals 7, when T equals -8, and R equals -2, and Q equals 5. So we're going to go ahead and plug these in and solve for K here. If we multiply both sides by 5, and we divide both sides by 16, -8 times -2 is 16, we get our K value, which is 2.1875. So that goes in right here, and my equation becomes this right here. Okay, problem 11 then. It says make each equation with the way in which R, or match each equation with the way in which R varies directly with T. So we're looking at just R and T here. So we can basically ignore the other variables. So we have R equals T in this case, right? If you ignore the other variables. Or R equals KT basically, because if you divide all the variables and make it a constant, then R varies directly with T. So we're looking for R varies directly with T in this case, and that's D. Okay. Next one is a little harder. We have R squared in the top and T's in the bottom. So I'm going to multiply both sides by T. And then basically you have R squared equals some constants times T if I flip it too, right? Because T's in the top here and R squared is in the top on the other side. If I square root both sides, then what I have is R varies with the square of T. So I know there's other variables involved. I'm just calling those variables K because there's some number. But I know R varies with the square root of T, which is E. And then the next one, R is in the bottom here. I'm going to flip both sides, so I have 5R squared T equals 5S squared over V, or times V. And then I'm going to divide both sides by T to get rid of the T. I'm looking at R and T. Now I'll square root the R, which means I'll have to square root both sides, so I really have to, if I was doing this for real, I'd have to square root everything. But that's going to give me R over, I'm going to ignore the top, just call it K. In the bottom I have the square root of T. So R varies inversely with the square root of T, which is A. And then the next one, I have R in the bottom here and T in the top. So I'm going to multiply both sides by 8R. I have ST squared equals 2VS times 8R. Now I'm going to ignore all the numbers. So let me just get rid of these and that. And I have R varies with the square of T. So directly with the square of T, which is F. And then the next one, R is here and T is here. So I'm going to ignore the other numbers. I have R cubed on this side. I'll move T to the bottom on the other side. And just call the other numbers K. Now if I take the cube root, we have R varies inversely with the cube root of T. If I take the cube root of both sides, so that'd be B. And then obviously what's left over is C, inversely with T if you solve this one for R. Okay, the last few problems are just translated from English into math. It says Y is directly proportional to X and inversely proportional to the cube of Z. That's how you translate that into English, which is B. Next one, Y varies jointly with W and Z. So W and Z would be the top, and inversely with X. So that'd be C. And then 3, Y varies directly as X and inversely with Y. Don't forget the K. That is A. Now obviously the other one's D then. And the last problem, L is directly proportional to R and T. Would be that equation, which you could write right there. All right, I hope this helps.